Yes friends, so question number 4 we are going to. Now first let me clean this. Now up to question number 3 we have completed, right? That is base theorems, extension we have taken, continuation, base theorem in continuation form or continued. Questions based on base theorem continued. We are taking some more questions. Here are taking 8 questions. For in the previous lecture series only 5 questions were there. These are word problems, word problems take more space. So only 8 questions are taken here. That one can understand what the basis of this. Okay, now take next question. Question number 4. What does it say? Let me take it. Now question number 4 is, first let me write here. Question number 4, what is given to us? Okay, question number 4 says, suppose a girl throws a dime. Alright. A girl throws a dime. Alright. Further it says, suppose a girl throws a dice, throws a die. If she gets a 5 or 6, means these two numbers, because there are 6 numbers in a die. So if she gets 5 or 6, right, in a die, she tosses a coin 3 times. If she gets 5 or 6, then she tosses a coin 3 times, and notes the number of heads. And then she notes the number of heads. Okay. If she gets a 1, 2, 3 or 4, means other 4 numbers, she tosses a coin once only. And first was, if 5 or 6 she was tossing a coin 3 times. Now she is tossing a coin 1 time only. If she gets 1, 2, 3 or 4 number, then she will toss a coin only 1 time, once. Right, and notes whether a head or a tail is obtained. If she obtained exactly 1 head, very important point, what is the probability that she threw a 1, 2, 3 or 4, means second event with the die, means she then once she, so when she got 1, 2, 3 or 4 number, these 4 numbers, then she threw a coin, tossed coin once only. Now let us take for the point here. It says, suppose a girl, this is not working. Let me take it. And suppose a girl, it says, suppose a girl throws a die, and a die, if she gets 5 or 6, what the point? She tosses a coin 3 times. This 3 times. She tosses a coin 3 times and notes the heads appear, number of heads, and notes. What does she do? And notes the number of heads, okay, and notes the number of heads. It says, okay, further it says that if she gets a 1, 2, 3 or 4, she tosses a coin, then she tosses a coin once only. She tosses a coin once, important point, right, once. once and notes whether a head appears or tail. Notes whether a head or tail is obtained, right? Is obtained. This is the event. If she obtained, further it says, if she obtained exactly one head, if she obtained, the word problem, that's why it takes time. If she obtained exactly one head, alright, one head, you find then, what the probability that, she threw a 1, 2, 3 or 4 with the die. Okay, with the die. This is the point here. Important point. And just try to understand. It's simple. So we will take here, there are two events here. That if she throws a die, and if she gets 5 or 6 means there are 6 total events, and out of that, if she gets these 2 events, 2 upon 6, so what probability of tossing a coin 3 times, before that she gets the probability of this throwing a die, right? Event A, A1, A2 are the 2 events, and B is the other event of tossing a die. Okay, so let me take this from here. Now we have understood the point, that what is the point here. Now let me find the solution. Here. Okay, let A1 be the event she gets 5 or 6. Right, she gets 5 or 6. So probability of A1 is equal to 5 or 6 means 2 upon 6. Why? Because there are 6 total outcomes, 1 to 6. Out of that she is getting 5 or 6 means 2 events. It is 1.3 and A2 be the event we have assumed here. She gets 1, 2, 3 or 4. That means probability of A2 will be, there are 4 numbers, so 4 upon 6. Why 4 upon 6? Because 6 are total outcomes in a die. If we are throwing, so there are 6 numbers, so 6 in the denominator. Out of that 4 numbers, if she gets 1, 2 upon 4, 1, 2, 3, 4, this is 2 upon 3. This is second event, because these are the prior events we are given. Now if she tosses a coin. Now if she tosses a coin, that means if she gets this A1 event, B is the tossing of the coin, right? B is the event of tossing a coin. What is that event? Let me first find that event. Okay, so B be that event. Let B be the event of tossing a coin. Let B be the event of tossing a coin. What is the probability of first case? Let me take it here. Therefore, solution B, let me take solution here. Therefore, probability of B upon A1, this be the event of tossing a coin. If first case, if she is tossing a coin, And what is the probability of that? Means C will toss a coin 3 times and C gets a tossing a coin 3 times and C gets a coin once only. Okay, so that case is 3 upon 8. Why? Why this 3 upon 8? Try to understand this point. Why? Because there are 3 times C is tossing a coin if she gets the first event. So A1 event is first event. So B upon A1 means tossing a coin 3 times and then getting head once only. So in out of those 8 outcomes, because if we are tossing a coin 3 times, then 2 raised power 3, that means total outcome will be 8. Out of that, head will appear only once in 3 cases. What are those 6 cases? Let me take them here. Total outcomes are 6 here. Try to understand. A coin is tossed. Total sample space will be H, 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 T. Let me take H, T, H, T, H, H. There are 3 double heads 3 times, and one head is H, T, 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 H, T, and T, T, H. These are 3 single-headed events, and finally total 3 tails. There are total 8 outcomes. Out of that, how many outcomes are having one head only? This is one head selection is 1, 2, 3. 3 events are having out of 8. So this is 3 upon 8. So 3 upon 8 is the event getting 3 heads. Oh, sorry, getting one head in 3 tossing. One head is 3 upon 8. So this is the probability. And probability of B oblique 8 is what? Well, in that situation, we are tossing a coin only once. In once, that means either 1.2 is the head getting the head is 1.2 probability, or tail is also 1.2, because there are two outcomes, head and tail. So out of that, one time head is appearing, one time only 1.2 is the probability of second case, getting what you call 1, 2, 3, 4, and then she is tossing a coin once only. Once tossing a coin and she gets head only once. So if she gets head only once, what is the probability of that? So this we have to find out. Now, probability of getting a head once, and that is in throwing a die in which the girl gets, she gets 1, 2, 3 or 4 is given by this event A2 by B. So by Bayes theorem, probability of A2 oblique B. Try to understand. So in the second case, we are getting tossing a coin once only. So this is probability of A2 into probability of B oblique A2 divided by probability of A1 into probability of B with respect to A1 plus probability of A2 into probability of B with respect to A2. This we have to substitute here. Now let me put those values here. Finally, this probability will be, by Bayes theorem, we have to find out this A2 with respect to B. Means B is the getting one head in second case. In second, throwing of a coin once only. So this is A2 event, throwing a coin only once. Okay, that is A2 event. Now, so this will give us this value, probability of A2. Probability of A2 was what? 4 upon 6, that was 2 upon 3. 2 upon 3 into getting head once only. This was 1.2. Second event, but B upon A2, that was 1.2 probability. B upon A1 is 3 upon 8, and this is so. With the probability, next one, 1.3, because 2 upon 6, 1.3. Probability of A1 is 1.3, 2 upon 6, right over 1.3 into probability of B upon A1. This is 3 by 8. plus these two values, 2 upon 3 into 1.2. Let me sum of them. So finally, what do we get? So we get here, okay, this 2 upon 3 to just 6, 3 to just, okay, 6 is there, no problem. But it's 2 to cancel out. So 1.3 in the numerator divided by 3 cancel out. This is 1.8 plus 2 to cancel out, 1.3 only. So in the denominator we are having 24 LCM, right? This is 1.3 divided by 24 LCM. So 3 plus 8, 11. 24 will come in the numerator, so 8 upon 11. It will give us, let me write above here. So this is probability of 8. So we were calculating probability of getting head once in second throwing. Okay, or it is in case when she gets 1, 2, 3 and 4. Second case was there. This is this value. This is 24 will come in the numerator. 24 upon 3. 3 was 1.3 was already there upon 11. So this 3 8 is 24. This is 8 upon 11. For 8 plus 3 11 in the denominator. So 8 upon 11 is the probability that she will get. This probability that she has got the head once only, and that is also in the second throwing. Second throwing is when she throws a coin, throws a die, and in throwing of that die, she gets 1, 2, 3 or 4, and then she tosses a coin once only. That is the probability of second case. That when she gets 1, 2, 3 or 4, then she tosses a coin. Okay. Let us take now question number 5. This is the answer here. 8 upon 11. Okay, this is the answer. So question number, finally we have done the fourth question number 4. Question number 4 is done. Let us take now question number 5. What does question number 5 say? Let me first read it and then solve it. So question number 5. But before that, let me take this. Yes friends, question number 5. Let us take question number 5. What is given to us? Question 5 says, given 3 identical boxes, first, second and third, each containing 2 coins. Okay, 2 coins each containing. In box number 1, both coins are gold. Okay, in box number 2 or second box, both are silver coins. And box number 3 or box number 3rd, there is box 3rd, there is 1 gold and 1 silver coin. Alright. Now a person chooses a box at random and tosses and takes out a coin. If the coin is of gold, right? If the coin is of gold, what is the probability that the other coin in the box is also of gold? That means if the coin he has taken out is of gold coin, undoubtedly this is from the first box only, because first box is containing 2 gold coins. When he has taken out 1 gold coin, the other gold coin is only in the box number 1. That we have to find out. What the probability that gold coin contained by every box is what? Okay, so the 3 boxes which are containing gold coins, what is the probability of those gold coins? And then it is taken out from the which box when the second gold coin will be a gold coin. What is the probability of that? So that we have to find out from the box number 1. So let me take what is given to us. Given here 3 identical boxes. 3 identical boxes. We are given here 3 identical boxes. Box number 1, 2, 3. box is first, second and third. In third, each containing two coins. Each containing two coins. No problem. Now it says in box number 1, or first, in box 1, both coins are gold. Both coins are gold. Right? In box second, both are silver coins. Right? Both are silver coins. No gold coin here. Both are silver coins. And both are silver coins. And in the third box, and in box third, one is gold and other is silver. It says one is gold, one gold and other silver coin, and other silver and other one silver coin, and other one is silver coin. This is to be given to us. Then what does it say? One gold coin is selected, one coin selected is gold coin. Then further it says a person chooses a box. It says a person chooses a box at random. Right? Choose a box at random and takes out a coin. This is given to us. If the coin is gold coin, if the coin is of gold, it is given to us. Then to find the probability that the other coin is, or other coin in the box is also gold. In the box is also of gold. Try to understand. This is the point here. So what the gold coins probability is given to us. First, gold coins are 2 upon 2 is 1. So first probability of first box is there are 2 gold coins here. So probability of that is 1. In second box there is 1 gold coin, in second box both are silver coins, no gold coins. So probability of getting gold coin from second box is 0. This is 0. And the third one, 1 gold coin, so 1 upon 2. The probability of getting a gold coin from third box. Now it says that first of all boxes are selected, so 1.3 is the probability of selecting a box. It says that a box is selected at random. So prior probabilities are 1.3. Then selecting a gold coin is given to us. So let me take all those events here. So let me take the solution here. So we are given here solution. Let me take. Let A1, A2, A3 be the events of selecting a box first, second and third respectively. Okay, these are the events of selecting boxes. Therefore, probability of A1 is equal to probability of A2 is equal to probability of A3 is equal to 1/3. Try to understand why. 3 boxes out of that one is selected. So its probability is 1/3, 1/3, 1/3. The probability of selecting a box first is 1/3. Now gold coin selection. Now let B be the event of selecting a gold coin. Selecting a gold coin. Selecting a coin gold. Okay, gold coin, let me take. Selecting a gold coin. This is the event which is required. Therefore, probability of first is B selected from this event A, selected from A1 event, right? So B oblique A1, first box is 2/2, or 2 gold coin are there in the first box. 2/2 into 1. And probability, probability of B upon A2, probability of B upon A2 is 0, because here silver coins are there, so no gold coin, so 0 upon something 0. And probability of B upon A3 is 1/2, because there is 1 gold coin in the third box and 1 silver coin. 1/3 is the 1/2 is the probability of gold coin.